one hello plus introduction to channel. So, firstly, hello. I'm going to be using this channel as somewhat of a journal over the next year, and be that in maths, be that in any other particular areas that I find myself interested in, educational wise, not just Dear Diary, today I petted a cat. Although that might come up, who knows. This is meant to be a journal, and it is intended, although I'm sure I will deviate from this path, it is intended to cover some things about algebraic geometry. So, this is a very intimidating title. So we need to unpack what this means. This applies a geometric intuition or structure to algebraic structures. Forgive me for my pen being I'm not all too sure. It seems to be having a mind of its own at the moment. So the geometric intuition on algebraic structures. We will see what that means. As another part of what I would like to do is to give a primer in not really basic level, but very early university level algebra. A keen high school student would be able to understand this. I am 100% certain of that. Primer in algebra. What spurred this is my my academic interest coming out of my master's degree. What spurred this is meeting up with one of my closest friends on, I believe it was last Saturday, and it's currently Wednesday. So last Saturday, uh, in we very rarely meet up, but we met up, and he told that friend of mine told me that he'd been missing something in his degree, which he said was thinking, which I feel is a little bit harsh on his degree. I'm not going to say what it is, of course, um, out of respect for him, but he, I guess reasoning would be a better word thinking about it. His degree is a lot of memorization and just this is precisely what the lecturer wants me to know, whereas my degree, like, it's not just memorization, it's problem solving. I it was a problem trying to think of a problem. Anyway, so meeting my goodness. Meeting with friend. If anybody knows how to undo on with this pen, I would be very grateful to know about it. It's an XP pen. I'm not sure. I'm not sure quite what it is in order to look it up. Uh, no, it just says graphical pen tablet on the bottom. But meeting with friend. The reason I'm starting this is my master's degree ends in a week's time, I think. Or no, next Saturday is the end of the exam period, and about a month later, I get to know whether or not I wasted 4 years and have nearly £50,000 in debt for nothing. I haven't. I didn't pay anywhere near that. I have student finance are just vultures. They charge very high interest, but at least their debt is not regular debt. Anyway, my interest coming out of my degree is algebraic geometry, which is the study of algebraic surfaces, algebraic sets, more basically, varieties, schemes. You have a little bit of topological stuff in there, like sheaves. I say a little bit. I'm not quite certain as to the extent. My master's degree ended up not being in algebraic geometry, but in category theory, which it sort of ended up being in algebraic geometry. I derived the boundary maps in cohomology using the snake lemma. If to h n plus 1 of... I ended up deriving this map. If you know what that is, then good for you. You should do if you continue watching, if I continue making this. The other reason for publishing raw thoughts to YouTube is accountability. I need some way of motivating myself to work, and if that means sharing my thoughts and my journal with some of the closest people in my life, then so be it. However, I think we had better get started with the primer in algebra very quickly. Or even more basically, a set... Oh goodness, I don't have a pen. A set... My... Right. My pen is being a silly sausage. A set is... some defined notion which tries to get around paradoxes, but it just sort of means a bag of things. There is a significantly more nuanced and significantly more thought out definition and more rigorous, etc., and then several more. For my next entry into whatever this ends up being, I think I need to introduce a universe, as is in the start of Francis Bourseau. As in the start of his work, I think just called Basic Category Theory, or An Introduction to Category Theory, something like that. It's from the 1960s, 70s, if I'm not mistaken. It's a very old book, but it's still very useful. Maths doesn't really change, and the notation hasn't changed that much in the last 70 years. I should actually rewrite that, but better. Francis Bourseau. What I want to introduce next time is a universe, which I think I should actually introduce that at the same time as a category. It doesn't matter. What I will be moving on to is, given a set, which I'm just going to write S, meaning set, and given a pair of sets, S meaning set and T meaning set, we can do a couple of things. So there are a couple of things. operations. So you have S intersect T, that's what this is, S union T, and S cross T, I think that is usually said. S intersect T is elements of both. This is elements of, I think that's how it's written, but I'm just going to say or X in T. This is taking where two sets coincide. This is taking everything. And what this does is given X in S, Y in T. What that does is it basically multiplies sets. So if you think about the number line, and I'm going to assume that you did some level of maths at the end of school, at the end of your school period, because the person who I'm making this for did. In fact, he did further maths, but my other person who I'm sending this to did not. But I will explain to her in more details. So, imagine you have the real number line and then the real number plane. This is the some point here, this is some point here. Oh look, it defines a unique point here. That is what this does. Only think of it as more discrete than that. And then this does a box. That implies that you have some sort of total ordering on both sets, this picture, but let's not worry too much about that. I need to erase this picture anyway. So how I will write function notation, because I recall that that was a little bit of an issue when I went over this in person. How I will write a function notation is, usually you will see functions written f of x equals y. That is how it's done in the end of school period. I don't know how to stage at the end of lower education. I don't know what to call it. At the end of school, or I guess it's also called college. Ignore me. When you're turning 17, 18, doing maths, this is how you would usually write things. I'm not going to say like. Please execute me if I continue saying like. But within higher maths, what we need to do is describe that this is within some set, this is within some set. Therefore, x is defined as taking elements of this set, the points here, and mapping them to elements in y. So this is somewhat confusing when you first encounter it, if you're not thinking, okay, why is this? So how this would be written is f takes x to y. And then if you want to actually give this some sort of declaration of what it actually is, you would write x and then a different sort of arrow, this one has here, which x to y such that x maps to f of x. And what it means for, let's say, let's give an example where it's this sort of set is not just one blob, but a bunch of things. So addition, specifically real number addition. Addition takes two real numbers. Goodness. Ah. Oh no! Does that remove everything? Oh no, it doesn't. Why am I on slide 4? Oh my goodness. Anyway, addition takes two real numbers and spits out a real number. So takes two real numbers and spits out a real number. Crucially, it takes everything from here and to each thing in here puts it into here. It does not necessarily take it to everything in here. In this case it does, however, oh my goodness, I'm terribly sorry, I've never really used PowerPoint before in order to note things down. So takes the pair of numbers a comma b and maps it to a plus b. An example of something which doesn't map onto functions which are of this form where everything in here is hit are called onto. A function which is not necessarily onto, and you learn about when you're about 14, is x squared, which I'm just going to say dot. Dot takes a real number and then spits out a real number. However, not every real number is spat out here if you're and such that x gets mapped to x squared. Not every real number is the square of a real number. This is where you introduce complex numbers. So what you can do is you can say, let's restrict the okay, so this side is called the domain. This side is called the codomain. You restrict the codomain. So, for instance, in this case, you restrict it to, that's meant to be a plus, not a dagger. A dagger means something else. Restrict it to a domain upon which it is indeed onto. Now, we ignore this example for now. It doesn't have its own special symbol, and it should stay that way. I am joking somewhat. It is an example of what will later be called a diagonal morphism. Oh no! A diagonal morphism where if you have a pair like this, it maps a comma a. It maps a to something a comma a. No. I'm so sorry. I should have gone to bed quite a while ago. I woke up 21 hours ago and have done a 4.5-hour exam today, so I'm feeling a little bit depleted. But we should be able to define a ring. So a ring is some set. Let's define a ring elsewhere. A ring consists of a set, an addition, and a multiplication, such that addition takes pairs in this set, spits out an element in the set, multiplication takes pairs in the set, spits out an element in the set, and we will write a comma b maps to a plus b, and a comma b maps to a times b. It's not very late. I just woke up very early in order to just explain why I've been up for nearly 21 hours. But these require having some axioms. The first is there is some element of S which doesn't change whatever number it's paired with for this and for this. Wait, that implies that they are the same. So they are different elements in general. Not always. So, for instance, there is a ring which is 0. And this is a very special ring which we will save for our discussion on categories. But this is a ring. I will give some examples before giving the actual definition. So the integers form a ring with the usual addition and multiplication. The real numbers form a ring with the addition and multiplication. The complex numbers form a ring with addition and multiplication. Unless you did further maths at A level, or I guess in IB, I'm not sure what IB folk do, but matrices form a ring with addition and multiplication. This and this will be interesting examples. These two will be two as certain examples. So this is an algebraically closed. Goodness, this is an algebraically closed field. This is a I think unique factorization domain, or no, this is also unique. They will have certain properties which we will discuss not now, but that should give you a hint that what this does is it unifies these notions of addition and of multiplication. So, what is a ring? A ring is a set with an addition and a multiplication, such that there is an unchanging element called 1, an unchanging element on multiplication called 1, on addition called 0, ignore the fact that they're crossed over, or I will fix that. And addition has to be, so addition, there is an element called 0, such that any number a plus 0 equals a. For any number a, you have some minus number called minus a, or its inverse is the correct term, such that a plus minus a equals 0. And you have a plus b equals b plus a, and obviously a and b are within here, b, and I guess we will need a c in there. And finally, how do we deal with larger statements? Well, we split it up. This is defined on pairs, so we split this into a pair, and oh look, we now have a pair. But we need for this splitting up to not really matter what direction we do. We do it in. So these are the same. And sense check 1 plus 2 plus 3 equals, well, 3 plus 3 equals 1 plus 5 equals 6. I think that passes our sense check, unless I've gotten something horrifyingly wrong. And there's sometimes an extra property called totality, I think is the word, where the sum of two numbers is also in here, but that is implied by this, so I'm not going to write it. But it's nice to know that that's there. Secondly, there is a number called 1 such that I'm not going to write times like that. I'm going to write dot, or I'm just going to write AB. You are smart enough to figure it out. I will actually write AB, such that A dot 1 equals 1 dot A equals A. And you might be thinking, let's write this, or let's write this. No, not in general. What would happen if we added this is this wouldn't be a ring. What would happen if we added this is this wouldn't be a ring. So neither this nor this. However, this definitely. So A, B, C equals A, B, C. And finally, there is something called distributivity, or the bilinear property. I will say the bilinear property. It is also called distributivity, and it can technically be written in two statements, but it's easier to write it in one, so I will just do that. We will also need a D, which is within S. All of these arrows indicate in, but from now on I will write that, meaning A is in X, or A is an element of X. That is what that means. But the distributivity rule is, how do these interact? Well, if I have A plus B times C plus D, we have AC plus AD plus BC plus BD. If one of these is 0, then it's either called left distributivity or right distributivity, in terms of like C is 0 or A is 0. So left distributivity can be thought of as B, C plus D equals BC plus BD. If we remind ourselves that multiplication sort of means area, then B, C, D, B, C plus D. This area and this area, imagine that they are equal. I'm just not very good at drawing, I fear. I don't know what that does. I think I actually do know what that does, and I'm not pressing it. But distributivity is the other rule, and that is all that you need to to define a ring. So it is a set with an addition and a multiplication, such that A plus B equals B plus A plus 0 equals A plus minus A equals 0, and then A plus B plus C equals A plus B plus C. And A multiplied by 1 equals 1 multiplied by A equals A, and A B C equals A B C, and A plus B times C plus D equals A C plus B D plus A D plus B C. Ah, yeah, this is the picture. So A, B, C, D, A, C, A, D, B, C, B, D. Do you, if you can't see it, then maybe put some glasses on. I don't know. It's like, yeah. uh, so that's a ring. That's what a ring is. So what I would recommend you do if you've never seen a ring before is specifically show that the usual addition and multiplication, verify, not show, that the usual addition and multiplication on integers forms a ring. It should, absolutely. These two kind of follow from the integers case, so don't worry about that. But matrices. Matrix multiplication, if you've never seen it before, I can introduce it. E, F, G, H equals, specifically square matrices, equals A, E plus B, G. So for the top left, you take this multiplied by this. For the bottom right, you take this multiplied by this. I seem to recall that the person who I'm doing this for doesn't actually know how to do matrix multiplication. Never mind. But verify whether or not the usual integers with the usual addition, but where multiplication is defined differently. Multiplication sends A, comma, B to AB plus A plus B. Is this a ring? From what I recall, it probably shouldn't be, and I would recommend either not trying associativity because it's just addition and multiplication here. That might not work. It might because it's, but I would say try distributivity and see if this falls out where AB is the usual multiplication of A and B. So whether or not the usual integers with the usual addition, but with this weird multiplication, I'm going to write tilde there. So A times with a tilde B. Or if you're feeling very, well, not very fancy, but if you're feeling like you want to cause yourself an issue later, then you write it with a circle around it, or just write it as normal if you're confident that you won't get confused. This, I think, is probably a good place to stop because my head is starting to hurt and I need some water and then need to go to sleep. But I guess if you made it this far, then thank you for watching or listening. I don't know. Whatever is done these days, off in the future, whenever someone's accidentally clicked on this. I don't know. A little tiny bit of housekeeping. Yes, this YouTube channel has been owned by me since I think about 2020. However, 2020? Yeah, I think roughly 2020. Um, the only videos that are on it, public, are of my dog. Privately, I think Minecraft Let's Plays, things like that. Um, things which will never again see the light of day, and I don't really like hearing my voice despite talking for a solid 35 minutes. I think it might be hard to believe, but yes. um, I think that it would be very useful for me to document and hold myself accountable uh, to some sort of regimen, and it being there forever will kind of motivate me to not miss a day or miss a week or miss a month. I don't know. I don't know how my scheduling will work. Um, my laptop doesn't have a very good microphone at all. My headphones, I'm not sure how good a microphone my headphones have. I just touched it. I don't normally use my headphone microphone. Headphone microphone. Yeah, I normally use my camera microphone, but that is bad, and I wanted the fidelity of the audio to not be awful. So yeah, I will upload this as a journal and go to bed, I guess. Mathematical Journal, 27th of May 2026. Uh, farewell. I guess I should write that. Where on earth is my pen? Is it in my pocket? Oh no. Oh, it's there. I'm just blind. Uh, farewell. Or I guess in Latin, vale. Or vale if you're Church Latin enthusiast, a Church Latin enthusiast. Okay, I'm drawing this out for far too long. Goodbye.